Hello once again. Welcome to Computational Linguistic Workshop. Today, Nataliia Sharonova, Marianna Dilai, and me, Yevhen Kupriianov, will host the workshop. So, the first reporter is Serhiy Dolgih, unsupervised semantic analysis and zero-shot learning of newsgroup topics. So, Serhiy, are you present? Do you hear us? Can you hear us? Okay. Okay.
Пане Євген, чуєте мене?
Так, чую.
Там це є четвертий воркшоп Вісікова. Він буде теж тут. Хтось один дзвонив, добре? Ви буде під тим, також під тим лінком. Добре?
Також буде...
Під тим лінком візьміть, прийміть, хай хтось виступить. Бо то вони, то Бісікало щось мав організовувати, а вони тільки на суботу всіх поставили, а на п'ятницю вони щось пропустили. Добре?
Добре, тобто два воркшопи за цим лінком.
Ну, я зрозумів, з того четвертого тільки одна людина, одна особа на цьому.
Тільки одна особа.
Послухаємо цю особу. Так.
Сергій Барабан буде про цього доповідача.
Так. Тут Сергій Долгих.
All right. So let us listen to this report you see on the screen, and then we shall listen to this. The second. Serhiy Baraban will be the second if there are no objections. Okay.
Okay.
Serhiy Dolgih will be the first to report, so you are welcome to present your research.
Hi, thank you. Hi, everybody. Glad to see everyone in this conference, in this great event. In a way of introduction, I work in the technology and science of information systems. Worked in the industry as an engineering, in the field of engineering of intelligent systems, in the telecommunications and security domains. And now do more research, focus more on the research and international scientific cooperation projects. The topic of this presentation is unsupervised semantical analysis of newsgroup topics. So it relates to the analysis of bodies of texts, corpora. How can we determine their semantical content? So for a background, there are, of course, approaches developed in semantical analysis in several directions, an increasing number of directions. One of them is supervised learning, which is based on a significant body of prior knowledge, for example, in the form of annotations, where texts are associated with some label, common indicating their semantical type or content. Unsupervised methods are based on the analysis of structure of the text, the characteristic features. And more recently, large language models emerged as a tool of choice in the analysis and generation of text. These are based on very large intelligent models, systems extracting information about the structure of natural texts based on very large bodies of natural texts without annotations. And of course, this same approach was recently applied to other types of data, not just text, images, audio, multimodal models, and this research is going on. So all of these approaches have essential constraints in one or several factors. For example, supervised models require large volumes of prior knowledge, such as annotations, large data sets, what we're talking about. While large language models really depend on huge resources in both operation and, most importantly, training. They are really based on very large bodies of training data. In this research, we set out to explore possibilities of analyzing small to medium-sized corpora. So this is not the entirety of natural language, but some specific collections of texts which are called corpora. And we would like to determine their content, what characteristic semantical messages or types of text they can contain without resort to very large resources such as large language models. Of course, it should be possible to achieve the same purpose with a large language model, but it may not always be available. Whereas these methods, which are demonstrated here, are very flexible and easy to apply to new tasks and new types of text, new languages. So they are quite flexible. So this slide outlines the objectives of the study. Now we're going more into the process, how these objectives are realized. And the first step, of course, is vectorization of text data. We begin with some sentences, texts, and we have to transform them into a numerical form so that some machine models, intelligent models, can be applied to the analysis of this text. And in vectorization, of course, there are very many approaches which have been developed over the decades. Here we are using the simplest, like one of the earlier ones, which is based on the term frequency, basically counting the occurrence of words, which is terms, in the text and making the decision based on the coincidences of occurrences of terms. There are reasons why we chose this approach. It's straightforward and the implementations already exist, so it's easy to begin working right away from the outset. It is sufficient for the demonstration of the approach which is proposed here, and it satisfies the objectives and doesn't limit the generality of what is proposed, in the sense that if we find another more efficient way of vectorizing or more precise way of vectorizing data, preserving its informative content, then it doesn't limit the approach which is demonstrated. So we follow those the pretty standard steps. I think people who work with text should be aware of this. Tokenization, filtering, stemming. So basically what we are doing here, we are pre-processing text, trying to preserve the informative content and removing extra pieces which do not contribute to the informative content of the message. What we obtain as a result is a sparse matrix of which represents the corpus. It's a text associated with some numerical vector, which represents its description or representation in terms of term frequency features. All of this is pretty standard and can be found in the text. So I guess the questions can go in the end. these are, in this slide, we show the model corpora, the text, the collections of text which were used to demonstrate this approach. It is based on a well-known data set of newsgroup posts, 20 newsgroups, and from this data set we created two model corpora based with some specific selection of topics. One of them contained a simpler one, had 4 newsgroup topics, and the other 7. Here is an example of a text in the newsgroup. So we are not talking about very simple text. We are realistic messages in the newsgroups. And as was said before, the standard methods of processing were applied to produce numerical representations of this text. So in this slide, we show just some characteristics of a resulting corpora, the distribution of text by the number of tokens, by the size. Again, we can see that these are not simple sentences. My cat is black, but realistic informative messages up to 800 tokens. This is after pre-processing, so we removed all the prepositions and other non-informative elements. So this can be pretty large text. And the table below shows the parameters of a numerical representation of this corpora, how they are represented by sparse matrix. What is sparse matrix? Sparsity. It means that like a vector which represents a text has a large number of zeros and relatively small number of non-zero elements. So most of a vector is zeros, and that's understandable because the collection, the corpus of terms, which is created on the basis of the entire corpus, can be very large, and not all of those terms can be seen in every single text. So of the entire corpus of terms, which has the size of, for example, for the news 4, about 35,000 distinct terms, specific terms. That's the length of a vector. But the maximum size of a vector would be 800. So out of 35,000 elements, only 800 would be non-zero in one of the texts. In others, it could be different. But what we are talking here is a very sparse representation of the data with small number of informative elements and large number of zeros. So the next step after we obtain these numerical representations of the text is to reduce dimensionality. The reason is simple. It's very hard. It's expensive and difficult to work with high dimensional data. And here in the sparse representation which it shows, for the simplicity of pre-processing, of course, it has its downside, but the resulting dimensionality of numerical representation is very high. So these are trade-offs. We could have chosen a more difficult, or more complex way of extracting data, but it would take more time and would be different research direction, different research results. So the objective we have now is to reduce dimensionality of this very sparse data. And secondly, based on the objectives of the study, which we discussed earlier, we want to do it in a way which doesn't use any prior knowledge about semantical content of the data. So we don't want to have our way of extracting low-dimensional representation and buildings of the data be dependent on prior knowledge about the content, because we want to determine content in the first place. So we can't be dependent on the knowledge about something which we will only want to find out. So for that reason, this puts constraints on the methods of dimensionality reduction. which are determined by this. First is that it must be able to work with sparse data. And secondly, that it has to be unsupervised. So it doesn't depend on the annotations. And such methods were developed over the years. In this study, we chose two. One of them is manifold learning methods, uniform manifold approximation. Another is also well-known T-distributed stochastic neighbor embedding. Another advantage of these methods is that they are nothing like large language models. They can be run on your laptop. They have standard existing implementations. So it's really as easy as taking some library and using it with your data. So here we have a demonstration of effective dimensionality reduction with the text data which we used in this study. Or here we have a new 7 more complex corpus. And here is how it is represented in 2- and 3-dimensional spaces. I'm not sure, maybe I'll just spend another minute about the semantics of the coordinates in this representation. So it's nothing related to the initial format of data, which was a term frequency. This is geometrical relations of proximity of text vectors, which we obtain in the first step, to each other. So it will be an interesting direction of research and tasks to try to understand the meaning of those latent coordinates, which we obtain through dimensionality reduction. This was not attempted in this study, but it's just as a note that it doesn't really relate to the term frequency anymore. It's informative features or coordinates which determine proximity of the text. So the last step here, the next step here is once you obtain those informative descriptions of the text in these latent coordinates, which are supposedly can differentiate, can first of all embed, and secondly differentiate between semantical content of semantical types of text in the corpus. We can try to identify characteristic structure in this representation. It is based on the assumption that our process of extraction was effective in the sense that it can retain informative content of the text. In this case, we can expect that texts which are similar in the meaning and semantics to each other will create higher density regions in this representation. We can see it visually, sort of in the diagram. The texts are really distributed in different regions, closer than overall in this entire latent space. Next, based on this assumption, if it's true, if it's correct, we can try to use some methods, again, automatic methods, and secondly, unsupervised methods, because again, we don't want to use a prior knowledge to determine this content.
I'm sorry. Your time is coming to the end. Could you please tell me more about the practical realization of your theoretical findings of your research?
Yeah, so sure. So what we do here is we apply a method of clustering, which is unsupervised based on density. And based on this, and as a result of application of this method, we can obtain the structure of density regions in the numerical representation, in the representation of texts of reduced functionality. And that can give us the ground to develop classifiers, methods which can determine the type, the semantical type of the text based on its geometrical location in the latent the latent representation space. So this slide and the article too, of course, describes these methods in detail. I don't think we need to go here. The important thing is that there are two methods. One is a bit more sophisticated than the other. But again, in the results in our study, we verify both methods and can compare their efficiency. So here are some results of verification of the methods which are proposed. One we use for determining the annotation, the annotated type of the text, and second, the accuracy of determining the natural type of the text. But as we can see, even with these simple methods, we can be pretty high, above 90%. This table just contains more detailed description of results. And here's just in conclusion, one of the interesting observations that we made is that applying these methods of unsupervised semantic analysis can actually give us more information than the initial annotations can be. You can see here, and this it goes a little bit out of the border, but you can still see it. But one of the clusters is divided in two parts. So the color here shows the annotation, the type of a news group, which is given with the text. And the red dot, indicates the center of the associated cluster. So we can see that one of the types, yellow, or it was type 7, class 7 in our news group, which is called Politics Middle East. It actually contains it seems to contain two distinct regions. What do we mean? Is it coincidental or it has some meaning? Of course, we can associate input text with their natural type just by recording the initial annotation and then prediction of a natural type by the classifier, which was created in the previous step. And then examining the semantic content of the resulting clusters, we can see that they really have a distinct semantical meaning. Smaller one is specific to Arab-Israeli relationship, while the bigger one is about general history, the relations between different regions, and so on. So those two regions have really distinct semantical content, which was not captured by the external annotation. That means that applying this analysis can provide us more information about the structure of the text than the initial, even the prior annotation, which was provided with the text. So conclusions, even this relatively straightforward form of vectorization, numerical representation of a text, we can obtain meaningful results with significant accuracy. We observed a structured geometry of geometrical distinction of semantical types in the text. Effective existing methods of clustering and dimensionality reduction can be used to identify the semantical structure of a corpora. And effective learning of semantic types is possible based on this informative structure of numerical representations. So proposed approach is general and can be extended to other languages, applications, and types of corpora. Thank you for your attention.
Thank you very much for your interesting and informative report. So please, any questions, if any?
Thank you for your attention.
No questions. All right. So, as far as I know, there are some reporters who were to take part in modern optimization and controlling in information and technology systems workshop.
Do you see my screen?
Yes, we can see it.
Okay.
And Sergey, before you start, so I'd like everyone adhere to our time schedule, so that everyone can present the report. So Sergey, you're welcome.
Okay, thank you very much. My congratulations to all organizers of this conference, sponsors, and participants. My report is dynamic random access memory based on fiber optic lines for optical computers, computer modeling. So the appearance of optical fibers with low losses and a large product of length by bandwidth is opening up prospects in optical signal processing. It becomes possible to create fiber optic devices when performing operations such as convolution, calculation of correlation functions, matrix operations, filtering, pulse generation, concatenations, pulse compression, and matched filtering. The basic element is a ring-type storage device on a fiber optic line in which information circulates in the form of a burst of optical pulses per second. So the aim of our research next, all the variants of optical dynamic the software of modeling fiber optic systems was used in the research. So determination of optical signal loss with a wavelength and the determination of influence of polarization mode, dispersion on the waveform, and the possibility of wave compensation. Determination of the optical input power value at which the linear mode of signal transmission is ensured. So here you can see the figure of a diagram which was simulated in OptiSim program. And here are the results of this simulation. So on figure 3, you can see waveform, spectrum, and the transmitter signal. And also on figure 4, you can see an eye diagram at the output of the optical signal receiver. On figure 5, you can see scheme for the study of losses in the 35-kilometer long fiber. This slide shows the waveforms of a transmitter and receiver and the eye diagram. And this is captured from OptiSim software program. On this window, you can see a diagram for studying the effect of polarization mode dispersion on the optical signal shape when passing through fibers. On this slide, you can see signal characteristics. A, it's our signal at fiber output, and B, it's an eye diagram of photodetector. Here you can see a non-zero dispersion shifted fiber with a negative chromatic dispersion compensates for the effect of polarization mode dispersion at distance of 33-35 kilometers, which can be used to build a dynamic optical operational storage device on fiber optic lines. This schematic was utilized to study the power level to be input to the dynamical optical operational storage device. And here are the initial parameters of a signal source which was used, of course. This slide presents the I diagram at a signal source power of 10 microwatts. And this slide shows the I diagram at a signal source power of 50 microwatts. Thus, at an input power of more than 10 microwatts, a non-linear mode of operation occurs in the fiber, which leads to distortion of the stored information. So to conclude, I can say that the results of computer modeling confirmed the possibility of implementing the dynamic random access optical storage device based on fiber optic lines for optical computers. To reduce optical losses in a dynamic optical random access memory, it is advisable to use the operating range of 1550 nanometers. To compensate special fibers should be used. A semiconductor optical amplifier can be used to restore the optical signal level. Optical signals are inputs and outputs through an electro-optical directional coupler. To work with optoelectronic memory on fiber optic lines, it is recommended to use a femtosecond fiber laser and the wave coding method. In further research, we will develop an experimental model of a dynamic optical random access storage device based on fiber optic lines for optical computers. So now it is a theoretical work. Relevant experimental studies will be performed. We plan to compare the results of experimental studies with the results of computer modeling and draw conclusions about the prospects of a proposed dynamic optical random access storage device based on fiber optic lines for optical computers. So thank you for attention. Questions, please.
Thank you very much. Dear guests, dear participants, you are welcome to ask your questions, if any. No questions. All right. Thank you, Sergey. Was interesting to know more.
Excuse me, we have a question here in our room.
We do have questions. Okay.
Yes.
So please.
In your modeling, did you come up with any restrictions on the distance of these optical lines, like how far the storage can be from the computer on the setting units to not interfere with the
but can you somebody repeat, because I don't hear?
It's hard to hear. So can you please come up maybe
questions,
here as well?
Sit, please.
We are without mics.
Take your seat, please. Question.
Yes.
So yeah, this is interesting research because it allows to provide some ground for development of distributed intelligent systems. Did you see any constraints on the distance from the processing unit to the storage unit in your research?
So as I told, the distance is 35 kilometers.
So this is the maximum then?
Yes.
Okay, thank you.
No problem. Thank you for question.
Any more questions? Thank you very much. And next, Marianna Dilai, Irina Khomytska, and Olesa Tatarovska with the report, a computer-aided study of the ideational metafunction in Penelope by Margaret Atwood. So Marianna, you're welcome.
Thank you very much, but Irina Dilai will present
Irina
the
will
speech.
be
Thanks.
presenter. Okay,
Mhm.
Irina,
Hello,
you're welcome.
everybody. Hello, everyone. Let me present on behalf of the contributors. So the topic of our presentation is a computer-aided study of the ideational metafunction in the Penelopiad by Margaret Atwood. Actually, we seek to explore computer-aided technologies aimed at informing and facilitating literary text analysis. And so it's common knowledge that literary text analysis, automated literary text analysis, on the one hand, contributes to a more objective discourse analysis, capable of revealing latent language dimensions. On the other hand, it serves as the indispensable basis for the emergence of AI text generating tools. So thus, the relevance of the computer-aided study of the literary text cannot be underestimated. So the purpose of this study is to investigate how meanings are construed in the narrative by conducting the computer-aided analysis of the ideational metafunction, exemplified by the novel The Penelopiad by a famous Canadian author, Margaret Atwood. First of all, let's clarify what language metafunctions are. So this term was coined and introduced within the framework of systemic functional grammar. And within this framework, they identify three language metafunctions: ideational, interpersonal, and textual. We here focus on the ideational metafunction, which is associated with the perception of text as a reflection of human experience. And its linguistic manifestation is ensured by different alternating types of processes or clauses in the text, which we are going to follow. The functional grammatical category, which reflects the unfolding of the process through time, and which denotes the transference of process from the subject to the object, is transitivity. Thus, the study of the ideational metafunction is often referred to as transitivity analysis. The objectives of our study are as follows. So first, we try to elaborate and test a transferable computer-aided methodology of text analysis based on the identification of different process types in the text. Then we conduct the statistical analysis of the distribution of the verbs in the narrative under study, applying unsupervised methods. Then we account for the quantitative findings, make conclusions, generalizations regarding the realization of this metafunction, and assess the advantages and shortcomings of the methodology applied. So our method is based on the following: individual verb forms or groups of verbs testifying to the realization of different process types are mutually related. They occur either close or far in the text, precede or follow other verbs, so they alternate within the body of the text. Thus, they form clusters, they form collocations, different structural units which are worth identifying and which testify to certain paradigmatic and syntagmatic relations of different types. Density-based clustering is aimed at identification of the verbs grouped in the areas of their high concentration in the text, and thus on the successful completion of our computer-aided experiment, we draw conclusion regarding the alternation of different types of processes, variation of different types of processes throughout the text, and thus the realization of the ideation metafunction within the narrative. It's worth mentioning that this kind of methodology can be applied only to narratives, because only in narratives we have the linear sequence of events and the linear alternation of processes. It can't be applied to dialogues, it can't be applied to plays or any other genres and text types. Thus, our research follows the following, consists of the following stages. First, we establish the frequency of use of verb lemmas in the work, identifying the most frequent verbs and pointing out the peculiarities of the author's choice, idiostyle. We compare the findings with the reference corpus, and in our case, the reference corpus was the corpus of Canadian fiction called Strathey. Thus, we can actually delimit the verbs which stand out in this work, in this very work, and function as key verbs. Then we categorize the verbs based on the prototypical processes and identify the respective lexicogrammatic and groups of verbs according to the Hallidaean typology of processes. We use the void corpus tool to segment the text into equal parts, sectors, and within these parts, we follow the distribution of verb forms. Using unsupervised machine learning methods and techniques, we establish differences and similarities data distribution and identify are used as foregrounding means, whereas all other types of processes are based as backgrounding means in the narrative. So based on the Yevhen tool, we can have the following, get the following distribution of processes within the body of the narrative. We can see that the distribution is different. Some verbs prevail at the beginning, some at the end of the novel. We can see the density of the verb forms appearing here. And then the same actually procedure was applied to verbal processes. And what is interesting that we can see that there is a kind of a mutual exclusiveness between verbal and mental processes in the body of the text. And we tried to measure it, applying a Pearson correlation coefficient. We can see that it is approximately minus 0.3, which testifies to moderate inverse proportional correlation. Well, we can see it actually on the chart. Then in the same vein, in a similar vein, we have identified the distribution of existential processes, and they normally prevail at the beginning of the novel, because here they introduce the characters, the setting of the narrative, and thus they are mostly used in the structures there is, there are. Distribution of behavioral processes is uneven, though some verbs prevail. And for example, in this very text, it's the verb to sleep. The results of our study are as follows. So as I've already mentioned, the existential verbs prevail at the beginning. The material verbs are the most diverse and distributed evenly throughout the text, featuring the highest degree of transitivity. The verbal and mental processes show a tendency towards inverse correlation. The behavioral processes are used as a means of backgrounding, and the relational verbs need either further manual research or more sophisticated techniques, because here we have polysemous verbs such as to be, to have, which can be not only relational. So we need more sophisticated techniques for their automated sense disambiguation. There are some methodology caveats. So the identified distribution of verbs and alternating processes does not reflect the spectral semantics of verbs, because some verbs have a longer duration, some can overlap with others, and some verbs denote repeated actions. Then the study of the linear distribution of the text of the data does not take into account, for example, Heap's law, though we had a small text. But anyway, according to this law, the rate of the count of the distinct words gradually should slow down, and the size of the vocabulary increases exponentially, which actually means that the words which appear at the end of the novel should have a higher functional value, even though they are used less frequently. Although the model easily identifies verbs, verb forms and their functioning, it still cannot handle verb polysemy. Of course, it has also advantages. It provides an objective, statistically verified text analysis. Thus, data clustering reveals latent patterning of linguistic features in the text. Due to the affinity of the structure of the narrative and the structure of the process, the methodology applied here and the findings of our research can be useful both for English grammar and English text analysis, not English text analysis. And so we reveal the advantages of the tool in conducting the language data distribution processing, making use of a variety of visualization, and the understanding of the alteration and mutual correlation of the processes actually sheds light and is a good feed for future text generation applications. So the conclusions can be drawn. The temporal structure of the narrative as a series of consecutive linear events is conveyed mostly by material processes profiled by the corresponding verbs. Thus the distribution of all other types of processes is more or less even, though some verbs stand out. The conducted statistical analysis proved to be effective in studying this linear distribution of the processes in the narrative. The analysis of the data correlation revealed their interdependencies, intricate semantic and structural relations within a text, oftentimes subliminal, and the clustering of the data appears to show the prominence of certain units performing either foregrounding or backgrounding function. And as prospects of further research, we can see the application of more sophisticated machine learning methods and techniques, especially deep learning, such as neural network and transformer-based models, especially for word sense disambiguation. Thank you for your attention.
Thank you very much. Any questions, please? Let me ask you, and which have you elaborated special software, or you used available tools to make your research? Which computer technologies in your linguistic studies?
Actually, we haven't elaborated any software. We have used the existing Yevhen tools software, but we have also used some other resources. We've used the corpus of the Canadian fiction, for example, and processed it separately. We have also used UAM corpus tool for some other purposes, especially for the transitivity analysis, and and also some Excel statistics was applied. We haven't, fortunately, elaborated any corpus tool because our research is more like computer-aided study of the text. Yes, so we tested the available tools.
Thank you very much. Any more questions? No more questions. Thank you very much. So next, so if there are any reporter from modeling optimization and technology system workshop, please show me your hand. Is there any reporter from this workshop?
So we have here one presenter from that workshop.
Mm-hmm.
Yes.
I would like to invite. So
yes.
I will differentiate from our workshop and from another workshop. Okay.
Okay.
Well, so please share your screen.
Just a moment. Just a moment. I will open. Okay.
So please, well, tell us
your-
whether you can see our presentation.
Yes, we can see it.
Okay, great.
Dear conference participants, let me present you the result of our research named Goal-Driven Situation Awareness Process based on predictive modeling. A couple of introductory words. The modern world has a lot of problem related to increasing complexity of systems we work with, and it is required to pass a part of our decision-making processes to intelligent agents available to this task is a very challenging task because it requires the implementation of the solution a lot of complex problems, such as using contextual knowledge, such as using and processing data from sensors, for example, taking considerations fuzzy and probabilistic character of knowledge, dynamic nature of knowledge, a lot of challenges. However, we have a very valuable source of insight. We can get a lot of usable information about how should we build our intelligent agents. And it is the human cognition, the human psychology, the learning of how human cognition works. And in the present day, we have some sort of discrepancy, some sort of differences between classical situation-aware models, some name them as intellectual camera or smart camera model. They are basically sequential. So the process is sequential. We first obtain information from sensors. Next, we identify objects in this information. Next, we may analyze this information, make decision, take action, and all this is sequential. While according to current understanding of human cognition, we as cognitive units, cognitive systems, we build models based on prediction. So sometimes people name it so humans work inside so-called controlled hallucination. So we hallucinate and we read information from our sensors as a secondary task, and we first build our anticipation of a world, of a situation we are in, and only next we take in consideration information obtained from outside world, from sensor. We reconcile to those kinds of information in the logically coherent structure. And the main purpose of this article, of this work, is to propose an architecture of intelligent agent following these insights from human psychology and human cognition. Another aspect of this proposed framework is taking into consideration the goals. Goals are a very important part of any cognitive agent, of any intelligent agent, because without goals, we don't have any autonomy of agents. They cannot prioritize their goals, prioritize their tasks, make decisions what is important, what is not important. So without goals, our intelligent agents is just another software system which blindly follow some sort of algorithm, and they don't have the possibility, the capability to change, to select task they are working with. We analyzed available works related to goals, the goal structure in humans, and it is interesting, but for the lack of time, I will only say that we'll represent goals, we model goals as a state of the world as anticipated state of the world, which will be either good for us, for agent, or bad for agent. So an agent can reach this state, actively seek this state, or it can actively avoid this state. Also, we analyzed the most useful framework for building and modeling intelligent agents called Belief, Desire, Intention framework, which exists a lot of time already. And this framework lacks this kind of very general, and doesn't implement situational awareness. And in our work, we focus it on situational awareness. In the classical situational awareness system, as already said, the most popular level model has 4 levels, which are essentially sequential and don't conform to current findings, current understanding in psychology, human psychology, human cognition. And the second part of my presentation, I will talk about the architecture, the proposed modeling system or intelligent agent architecture. We model situation-aware intelligent agent as a set of interrelated, dynamically constructed conceptual models processed by corresponding functional models. The knowledge is represented is modeled as a knowledge graph when this concept related by edges, and each concept and each edge has a weight. And in order to know with which concept use it in current moment, which are relevant to specific task or relevant to specific problem, we use the attentional mechanism. So we just cut off unrelated concept, unrelated connections between concepts which have lower weight. The modeling structure has 4 main functional models here. Each functional model works with its own contextual, conceptual model. And let's talk about each model in specifically. And before it, I would like to say that we differentiate between 2 terms, context and situation, which is all sometimes in scientific articles confused. We understand context as environment in which our intelligent agent exists, plus intent of this current intent in this environment. So these 2 things together. And the situation is a possible condition, change in some sort of event which happens in current context, which requires some sort of action. For example, for a driver and the car, this context could be a task, driving a car, and the environment, the car itself, the road, and the objects along the road. And the situation could be, for example, an animal crossing the road or pedestrian crossing the road, low gas in the car, and so on. The center place, no, it is a bit before. The central place is occupied by context processing model. Context processing model obtains intent, so the smallest goal from goal system model, and it has a contextual model which includes the model, the relevant elements from the environment related to the task, and the other element may be obtained related to this task, not exactly from environment. I must stress that all models work with the same knowledge base, the same ontology, so they don't need to align the ontology, the concept within this ontology. The intrinsic system is a goal processing or goal system model, GSM. It works with a system of goals, and goals, they are very different. They are a set of goals. They form all sorts of structures, and the most typical structure is a chain of goals, like final object goals, for example, and approximate goals in the path to this final goal. This will be kind of a chain structure of our goals. And each goal has related weight or motivation, which could be either positive or negative. And this motivation is dynamically always changing because we should assess the related importance of other goals. So this motivation is changing. As an intention, as I already said, is smallest goal. The smallest goal we can follow, we can in each moment. And the goal system model selects the most important intent and pass it to the contextual model. Yes. In this slide, we have a couple of usable functions associated with the functioning of this goal system model, such as assessment function, the matrix of distance between two states of goals, the weights of relationships. We also discuss how goals are influencing other goals, how the weights are passed from more important goals to the proximate goals, and so on. And I will pass to the next functional model, is the model related to detection situation. Situation model works with environment model, and it analyzes all sorts of cues with the possible related to possible situations. Situations are taken from our previous experience. So this is if some cue is detected, this model has the ability to ask for more information from the environment model, clarify if the existence of situation is confirmed. A new goal is created, and this new goal is passed to goal model. If this goal is important one, and if it will require some sort of action, it will next be selected and passed to the contextual model. So essentially, this situation detecting model works with finds the situation, detects the situation. Next model is environment model. It a separate model which incorporates function from the 0 and the first level of situation-aware models, and it works with sensors and identifies and interprets data obtained from the sensors according to local ontologies, And also it works with external agents, external sources of information. So it is a kind of portal or door to outside world, to us. And next, we have the action model performing the intent. It is the combined work of contextual model and execution model. They work, they obtain the intent from the goal model, and they read the how-to knowledge, how to implement this intent, what is required, which kind of commands need to be executed or actions should be executed in order to perform, execute, or reach this intent. So it is the final model. Okay, I believe that this architecture based on predictive modeling will be useful to build an advanced agent, because as multiple millennia of human evolution, of human cognition, they have shown that we have a very useful and a very something good cognitive systems. So there are multiple advantages to use insights from the psychology, the construction of intelligence. Okay, thank you for your attention, and please questions.
Thank you very much. So, please, any questions?
Yeah, I have a couple of questions. I had some searches and some opening. First of all, can you hear me?
Yeah. I will repeat, maybe.
We have some questions here in our room. Can you hear us?
I will repeat your question.
So please, any more questions?
What is the format? Should I come here? Like,
Yes, maybe come up here. Yes, it will be. Sorry for that.
We can't hear.
You stay, please stay. I will.
oh, okay.
Let's move a bit.
So first of all, no, I will be sitting. Why is it important? Can you comment? Why is it important? You mentioned it at the beginning of your lecture for an intelligent system, for a complex, a very sophisticated intelligent system like a human being or independent agents to have its own detailed and correct model of the environment. Why is it important to construct such a model?
That is interesting question, and the model of environment is well, human person. It is important because we should make decision acting in this environment. If we don't understand this environment, we can make error, which can be sometimes be fatal, little errors. And it is interesting that human cannot grasp the whole environment so they should differentiate because they have inherent limitation in their computational power, computational limitations. So they should select a small number of really important things from this environment and relations between them.
And related to
coherence, and related to their intent, because intent works as a filter to select objects from environment. So related to intent works as a filter and creates criteria to select those elements from the environment.
When the environment is complex and we intend to make certain decision or certain action, if we don't have this internal model which describes it to a certain level of precision, they can break something. So they will act one way, but it will be compatible with some other domain which we don't have an attention. And this is why it is important for us to have this integrated model of the environment. So
Yeah,
does not some other consequences.
And that's why we have a situation detection model, because situation works like a watchdog, and it looks for some kind of unpredictable events, which can happen, dangers and something like this, which can happen in our event when we should react to those events.
Thank you.
Thank you. Thank you very much for your questions. Okay.
So on those segments, the essential critical to this model.
Yeah.
So we have two situations. One is an artificial system, for example, intelligent agent, for which we probably the goals are defined by us. So we want it to behave in certain situations in a certain way. So we tell it kind of what your goals are. But what about the natural system, which is developing by itself, naturally? Who sets the goals for a natural system?
Natural systems goals refined. I think that goals are refined by feedback mechanism, and in our natural system, we monitor the success or fail of our previous goals. And depending on success or fail, we either encourage our bias or principles, or we discourage those. So they are either strengthened or otherwise. Okay, thank you. Maybe other questions for me.
So I think that we shall proceed to our next report. Thank you very much, and I wish your developments implemented successfully in our practical life.
Thank you.
My personal plea. Everyone who will take part in discussion, those who are participating online, please go close to computer microphone, because the discussion, the rest of discussion was not heard. Everyone, please go back to computer closely, so we can, the rest of us can hear. All right, let us go back to our computer linguistics area. And now, Irina Khomytska, Irina Bazilevich, Vasil Tesluk, Valentina Holtran, and Olena Duritska presenting the report, the chi-square test and the students' t-test used for authorial style characterization. Well, so
yes, just a moment. We are sharing our presentation. Just a second.
So we can see it.
So can Well, can you please tell us whether you can see the next slide?
Yes, we can see.
Does it work?
Yes, it works perfectly.
Yes, but we cannot hear you right now.
Yes, it works perfectly.
And can you hear us well?
Yes, we can hear us very well.
So, let's start.
Dear colleagues, dear researchers, our report is dedicated to authorship attribution. There is an increase of attention to the problem because the results of this research have a wide application. In cases of slander in the anonymous letters, in documents, in forged documents, in copyright infringement, and other violations of human rights. Actually, what we researchers do in this case, how we try to reveal the patterns the author follows, yes. So first of all, I must say that there is a specificity of the image the author creates, yes, which depends on individual way of thinking, on individual psychological perception of the reality, yes, and individual perception and individual associations related to every life situations. And all these factors taken together create some image of the reality. And we researchers are to reveal the patterns the author follows. Yes, in most cases, we analyze the word stock, that is the most frequently and the least frequently words. Yes, in order to disclose the specificity of the authorial reflection of reality. As far as topicality is concerned, the problem is still topical. Yes, there are lots of approaches to this problem, and the research is done on different language levels and different methods applied, machine learning methods, the classical methods, yes, statistical tests, yes, but all these approaches and methods have their limitations, you know, and they are efficient on certain language level, yes, on certain linguistic material, yes, and these methods aren't universal and you cannot apply them, yes, to any text. So that's why it is topical. It is topical to propose certain approach which would be more or less universal and suit all the language levels, yes, and will be efficient for all linguistic material, you know. That is the problem. Yes, as far as the analysis of recent publications is concerned, so we can see that the machine learning methods and classical statistical tests are mostly used, yes, and they may be used either separately or combined, and very good results are obtained with the help of convolutional neural networks, CNN, yes, as well as yes, as well as deep learning models. Yes, these methods have been used to detect aggression in social media. Yes, so they analyze some emotionally colored content. The purpose of this research is to prove that the chosen classical statistical powerful tests, the chi-square test, and the students' C-tests are efficient, yes, for differentiation of tests by parts of speech distribution and phoneme distribution. And what is the novelty of this research? Yes, that the chi-square test has been applied to analysis of parts of speech distribution for authorship attribution. The research has been done on the material of bell-letter style, American emotive prose, and British emotive prose, and drama, and scientific style, classical mechanics are involved. What is the algorithm of the applied method? We calculate absolute and mean frequencies of occurrence of phonemes, and then we apply the student's t-test, and then we calculate relative frequencies of occurrence of parts of speech and apply the chi-square test. The chi-square test, the formula is on the slide. And as far as computer program realization is concerned, so the software has been developed in Java, and the system, the structure of the system is based on a modular system, on the modular principle, on the modular principle, and there are the following classes. Main, the class in which we just upload the research text, sample processor, we transcribe English text. Yes, and in the class parts of speech processor, we just form a sample of parts of speech. And the same goes to phoneme processor, we form a sample of phonemes. Yes, and we calculate mean frequency, relative frequencies of occurrence in the class parts of speech utils, and mean frequencies of occurrence in the class phoneme utils, and we apply the chi-square test and the student's t-test in the class statistic processor. As a result, we have obtained two samples. Yes. The results are for the analysis of American emotive prose, Harry Potter and the Philosopher's Stone by Rowling and Sabrin by Ashley. So the results applied, the results obtained show that the
what are the numbers here? Just to understand.
On the previous slide, some numbers.
That is a sample obtained, yes. Frequencies of occurrence, yes, frequencies of occurrence. The sample on the basis of which we can obtain the results with the help of the there's a sample on the basis of which we can apply the statistical test, the chi-square test, and the student's t-test. These are this is just material for application of the statistical tests, the chi-square test and the student's t-test. Just for the student's t-test, we had to calculate absolute frequencies of occurrence and mean frequencies of occurrence.
I'm sorry. Sorry, interrupting you. So have we finished? Is the report over and we move to discussion or what?
That the homogeneity hypothesis is rejected. And this means that the differences between the compared texts are statistically significant. Yes. And for the student tests, we also obtained statistically significant differences. Yes, for student tests, with the help of the student t-tests, we analyzed the British bell letter style that was shows drama, violence, emotive prose, and scientific style, classical mechanics. The level of test validity is 95%. Conclusions. So actually the goal of this research has been attained because we managed to prove that the chi-square test and the student's t-test are powerful, yes, efficient tests for text differentiation, for style differentiation, for authorial style differentiation by parts of speech distribution and phoneme distribution. It should be also mentioned that as far as the research with the application of the students' t-test is concerned, 3 cases of phoneme positions were used. There was a phoneme in any position of the word, at the beginning of the word and the end of the word. And it's very good. The very good result is that in every case of the position of the phoneme in a word, the groups of phoneme have high style and dorsorial style differentiating capability. So for there are 8 groups, phoneme groups, and the differences are statistically significant actually for every group in every case. So we can say that these tests are powerful and efficient, and recommended, yes, to use them for authorship attribution in the future, and we can use our result just for the text with all sorts of human violations, slandering, anonymous letters, yes, forged documents, yes, yes, and for authorial style differentiation in scientific papers and literary works, yes. And in our future research, some syntactic features will be chosen for style and text differentiation, and the material will be different. Different functional style will be chosen, as well as there may be another combination of only classical or maybe classical and the machine learning methods combined. The presentation is over. Thank you for your attention.
Thank you very
Yes,
much.
well, we have kind of issue with volume. Somehow we cannot hear the participants from Zoom. Just a second, I will deal with this situation somehow.
So,
just a second, we have some issue with volume, so we cannot hear those participants in Zoom. Please say something to us so that we can check whether we can hear you.
all right.
Oh,
so
great. So we can hear you now. Thank you. Thank you very much. Yes, it's kind of magic, because when I show presentation, somehow some issues with volume I have. So questions here?
Please, any questions to the reporter? No more questions. Well, I'd like to ask you. You said that you applied software to determine the author style, taking the letter works as example. Is that your own elaboration? Is that your own program, or you used available tools?
was program elaborated by my co-authors, yes, and we used this program in our previous research. But what is new that it's the first time that we differentiated the text by parts of speech distribution. So there was a change in this program. Yes.
So it would be interesting that you include some details in your presentation, in your further reports, and would like to know something about algorithms by which the author style is determined and their advantages according to analogs available at present time. So it's I would like that you next time present your elaboration of your co-author.
Thank you very much for your recommendation. Yes, thank you.
Thank you very much. So any more questions? No more questions. All right. So, and I'd like to skip to another workshop authors if we have. So, please, any reporter, if there are any reporters from Modeling Optimization and Technology Systems report, I would like to invite to present your report, if there are any colleagues. No more?
No, we have no more. We have one more in computational linguistics, yes, according to the program.
All right. So Olga Lazinska will be the next to report about statistical translation method for Ukrainian sign language.
But well, I'm not sure whether she is actually present because she is not here in person in our room. And well,
according to the first part of the workshop, we can, Olga Lazinska is the last for the first part. And my suggestion is as follows. We have two options, continue working up to 12 o'clock, or we can make a coffee break now. So, coffee break? Or
so we can continue. We have here some participants who are ready to present their papers. So,
all right.
Yes,
So,
for example, Solomia Albota, yes. So,
Solomia, well, please.
Yes, she's coming here. Just a second, yes. Okay, so just a second. Okay, I'm sharing the presentation.
So where is your, so we can see it. You're welcome.
My research entitled Linguistic Representation of Ukraine in English Language Media Discourse, a corpus-assisted approach. So since Russian-Ukrainian war, news articles soared dramatically, media discourse has been involved in disseminating narratives about Ukrainian position imposed by martial law and military actions. So the purpose of the paper involved two approaches. It's kind of two-based complex linguistic analysis. So corpus-based analysis and textual semantic analysis. So media corpus encompasses information and clarification of disputes, effects of vox populi, and discussion focusing on finding approaches to mutual agreement. By analyzing genuine text, a corpus-based methodology has the potential to reveal aspects of language that were previously unknown, offering a fresh perspective on the nature of language. So in this paper, the intention is paid to this complex linguistic analysis, and the methodology is the following. So corpus-based approach to the study envisages the use of the following methodology. So application of sketch engine software to conduct keywords analysis of the English trans corpus, then using of sketch engine software and Voyant textual software to discover collocations based on the words allocated by these keywords analysis, and textual semantic analysis of the corpora statements within the concordance on the basis of collocation occurrences and identification of semantic prosody of media discourse themes. And all these stages are being permeated with a linguistic interpretation, incorporating lexical patterns and their interpretation. So firstly, having set the criterion using sketch engine for the corpus query within the new genre of the media discourse of the target English trans corpus and reference English web corpus, the following list of corpora keywords with their line numbers have been obtained. So we have got the result that Ukraine holds the 6th position, Kyiv the 7th position, Ukraine's the 8th position, and Zelensky the 10th position. So the frequency values as well as keenness score have been calculated. And here is the table depicting the frequency values as well as keenness score in their descending order and taking into account statistical values, not the line number mentioned. The next two figures, so they show that just we refer to Ukraine covering not only a current military state. That is why one of the research tasks is to discover media discourse themes and further define their semantic prosody. Now the fact is that the frequency value of the word Ukraine within the target corpus, 348.33, is higher than any other keyword in the corpora, even outbidding COVID, advertisement, and Getty. What is meticulous about analysis in synchrony, that second column represents the statistics of the reference corpus of 2021, and judging from its values, there were low indicators of these lexical patterns, which means that only after 2022, a vivid debate about Ukrainian state took place, unlike the second column of the opposition, whose territory aroused interest only before the Russian-Ukrainian war. So now, on the basis of keywords analysis with the help of a word sketch corpus management tool, a grammatical and collocational matter of the word Ukraine is being considered. In comparison to other collocated in this figure 5, it has been calculated that the highest frequency value of the collocation is that which constitutes the concordant statements of the year 2023. So the strongest collocate is Moscow in a relation to noun modified to Ukraine, 10.3. However, when analyzed linguistically using textual semantic analysis and linguistic interpretation to the previous concordant statements of the collocation in figure 6, so conflict issues with the opposition have been revealed. Then the next figure shows the collocate Moscow in terms of the opponents per day. In comparison to the statistics of the corpus, English language media discourse in 2024 demonstrated Ukraine by war and invasion the most frequent. With an aim to prove the perception of Ukrainian state by English language media discourse, the Wine software tool has been applied. So we can scale this buoyant visual image in a downward position. And the first word after Ukraine goes year 2022, then month February, then invasion. And such lexical patterns as Russia, Russian. So the first word of the latter lexical pattern was not inherent to keywords in that previous table one. However, it was noticed in visual representation of Ukrainian perception via Voin 2. So among the collocations we may name after zooming president, military, Europe, security, sanctions, forces, border, troops, support, people, crisis, conflict, government, allies, attack, minister, Crimea, aggression, weapons, threat, tensions. The most frequent word was president, 1,488 occurrences, demonstrating interest among foreigners and inspiring trust among population. The next linguistic stage was to define discourse themes within English trans corpus using textual semantic analysis and linguistic interpretation, as well as contextual analysis of the corpus concordance statement. So the first discourse theme of year 2020 was not marked greatly with the perception of Ukraine. Only these 4 collocations represent negative semantic prosody referring to the humiliation of Ukraine. 2021, here we have less corpus concordance statements, unlike the previous one. And in the following themes, a shortage of statements due to their size and intention to demonstrate a variety of collocations was considered. So this theme is characterized by frequency of such lexical patterns as threat, tension, escalation, aggression, weapon, military action, attack, fears, invasion, crisis, and variety of synonyms and synonymic collocations to the war precedents like unrest, conflict, aggression, escalation, aggressive action, military action, invasion, tension, military threat, military fear was considered, which only intensifies the calamity. Next, a discourse theme of the year 2022 was illustrated with the most number of corpus statements, 45,564, highlighting this tragedy of Ukraine, this Ukrainian genocide, and there are lexical patterns of invade, invasion, invaded, will invade, has invaded, signaling the semantic divergence between the previous discourse theme and this one. In 2023, this discourse theme was characterized by decreasing the amount of corpus statements. So unlike the previous, it has only 16,857. So mainly represented by such lexical patterns as support, defend, provide, transport, boost, supply, liberate, send, prevail, help, and win. So they all were characterized by changing their forms by only in present times, which can be linguistically interpreted as a willingness to overcome lust for torment and hope for support and inevitable victory. And current year 2024, as it still has just started, so in comparison to the previous themes, there were only 1,352 corpus statements for 1 month, January, and perception of Ukraine may be linguistically and semantically discovered by such debated topic that remains still as a support for Ukraine. And now continued aggression, this collocation was added to the synonyms to ongoing war and current war. Last discourse theme uncovered political and manipulative tactics of withholding military aid for Ukraine in order to lose this battle. And there is a table just for semantic comparison of prosody of discourse themes and statistical data. So each discourse theme is permeated with Ukraine, 2 years before, where negative semantic prosody was only slowly growing, either to recall the eternal conflict or to overcome the opponent. The year of the war, 2022, and 2 years afterwards are characterized with bitter military action and strife for sovereignty. And of course, there is a dominance of this negative prosodies. There is still positivity that has been achieved by those heroes who defend our land, foreign partner support, and world justice. So for those 2 years, lexical patterns underwent a move from current conflict, ongoing war, to continued aggression. So both lexically and semantically military abscess in Ukraine was considered. Negative semantic prosody permeates the representation of Ukraine in news coverage, mainly in American, British, Australian, and Canadian reports. However, by 5.44% lower than negative prosody, positivity was expressed by a great amount of direct speech and utterances, predicting success of Ukraine and inspiring it with a hope for a bright future, along with the support of partners. So it would be valuable to linguistically analyze linguistic corpora of various genres and conduct comparative analysis of representation of Ukraine, both in international and domestic arena. Thank you so much for your attention.
Thank you very much. Any questions, please? Maria, you're welcome.
Yeah, thank you for this interesting talk. Did you compare it with with other corpora, for example, Ukrainian trends? It would be interesting to compare with the situation in different languages, at least with Ukrainian.
Thank you so much. Yes, as I used the Sketch Engine software corpus management tool, so that's why only English trends was available at that time, no Ukrainian, but yeah, it would be much further, yeah, isn't interesting to compare both English and Ukrainian as well. Thank you.
Ukrainian trends, this corpus exists, and it has been downloaded since the beginning of 2022.
So I have just started this corpus something, and that's fine. Okay, thank you for your recommendation. Thank you.
Well, any more questions? Okay, if there is no questions, we can move to another report. So, Marianna, tell me, please, from another workshop, if there are any reporters?
Well, not ready for this specific time. Yes, maybe after the break. Yeah.
Olga Lozinska is
Olga
present.
Lozinska is, yes. So Olga Lozinska.
Okay, so let us invite our reporter. So let me present your report. So statistical translation method for Ukrainian Sign Language by Olga Lozinska. Will you please share your presentation?
Yes, so we are sharing the presentation.
Так, папочка. Ой, так. О, бачите, є така штука. Але, тут так. Так, шукаю. А ще два скинули, чи? Зразу відкривай. Статистика, так. Ну, дивіться.
Well,
Yes, yes, we are in the process. Just a second. Yes, so I'm sharing the presentation. Yeah. Here it is. So can you see it?
yes, we can.
Hello, everyone. I am Luzinska Olga, Associate Professor of Information and Network System Department, and topic of my presentation is Statistical Translation Method for Ukrainian Sign Language. More than 44,000 people with hearing impairment are registered with the Ukrainian Public Organization of the Disabled Ukrainian Society of the Deaf. The World Federation of the Deaf unites more than 70 million deaf people around the world. People who communicate in sign language should be provided with comfortable access to modern information resources. To achieve this goal, it is necessary to solve the difficult task of translation sign language into a corresponding text record. Sign language is a natural language with a grammatical structure and vocabulary that differs from written languages. The translation of Ukrainian Sign Language is a complex task, which includes the analysis of the grammar of USL and construction of rules for the translation of Ukrainian Sign Language into text and vice versa. The main problems of computer translation from Ukrainian Sign Language into written Ukrainian and vice versa are: sign language grammar differs from written language. The order of words in the sign language sentence is of great importance. The number of words in sign language does not correspond to the number of words in written language. And use of the dactyl alphabet, pointing gestures, transliteration of proper names and terms along with gestures in Ukrainian Sign Language. Proposed methodology. Statistical sign language machine translation systems use bilingual corpora that contains complete sentences. The first problem is the lack of large corpora. Existing corpora use gloss notation, one gloss is one sign, which is too complex to learn. For Ukrainian Sign Language, we have created a corpus of more than 230 sentences, which contain sentences in the Ukrainian written language and their translation into Ukrainian Sign Language, taking into account the basic rules of translation. The second problem is the lack of a standard for notation of signs. To indicate signs, we will use glosses. The word is written in capital letters. For example, we write the word Zhinka in Ukrainian written language with capital letters to gloss. Difference of word order in Ukrainian written language and Ukrainian Sign Language sentences. The first case is the same order. We have the alignment function 1 in 1, 2 word in 2, 3 in 3, and that we have the same order when we translation into Ukrainian Sign Language. In the second case, we have the alignment function is first word in first, 2 in 2, 3 in 4, and 4 in 3. We can see that the adjective in Ukrainian Sign Language stay before noun, and in the Ukrainian Sign Language,
the adjective stay always after the noun or pronoun. The third case, we have alignment function 1 in 1, 2 in 2, 3 in 2, and 4 in 3. We can see that we use auxiliary verb in this case, and in the another case, alignment function is we have the interrogative sentence. When in sign language the interrogative word is always stay in the end of sentences, then we can see that alignment function is 1 in 2, 2 in 3, 3 in 1, and 4 in 4. The result. The simplest statistical translation model is the literal translation model known as the IBM number 1 model. This model assumes that for each word in the USL sentence, there is 1 or 0 words in the Ukrainian written language sentence. Let's consider the application of the EM algorithm, expectation maximization algorithm, on the simplest sentence. We have table 1 shows several iterations on 3 sentences of the corpus with 4 input words. Я пишу наукову статтю, and the translation in Ukrainian sign language, я писати стаття наукова. First, the probability of translation from a sign language word to a verbal one is 0.25. Given these initial probabilities, and using the EM algorithm, we calculate the iterations of the EL algorithm, and the final probability is 1 to the most correct translation word. Also, we generalize the alignment matrices for sentence types of the same structure. As word alignment, the first case, we have a word alignment matrix for types of sentence, noun or pronoun, verb, noun or pronoun. The second, we have word alignment matrix of 4 types of sentence, noun or pronoun, verb, adjective, and noun or pronoun. The third case, we have word alignment matrix for types of sentence, noun or pronoun, verb, auxiliary verb, and noun or pronoun. And the another case, we have the matrix, word alignment matrix for types of sentence, noun or pronoun, verb, and pronoun, adverb, numeral, and this is a case for interrogative sentence. Conclusions. The analysis of the obtained results showed the expediency of using statistical machine translation for Ukrainian Sign Language. In particular, the IBM number 1 model was used to translate USL words into Ukrainian written language, and the EM algorithm to align words in sentences. Experiments were conducted on the corpora of parallel sentences, Ukrainian written language, Ukrainian Sign Language, which contains 230 sentences. In addition, alignment matrices for sentence structure of the same type are generalized. The practical value lies in the possibility of translation from Ukrainian Sign Language to Ukrainian written language, and vice versa for people with physical impairments. The following studies will focus on a more detailed study of neural machine translation for Ukrainian Sign Language. Thank you for attention.
Thank you very much. Please, any questions, if any? No more questions.
Question here in our room.
Did I understand correctly what you...
Please close it to the microphone.
So, yes. Yes.
I'm not familiar with this problem. Do I understand correctly what you describe gloss is has a one-to-one relationship to the sign? So once you know the gloss, you can translate it to the sequence of signs. Okay, then it looks to me that we really, as you mentioned in the conclusion of your presentation, using the machine translation methods like deep neural network based should be a very effective approach to this. Because it's been very successful with translation between natural languages. This seems to be a kind of a translation. The only thing is that, of course, you need a much larger corpus.
Yes.
So it's
like
yeah, I mean,
it's a very, very big problem. I create this corpora and we use the pedagogue from Ukrainian deaf school in Lviv. They correct this corpora. That's why, but it's very long process.
exactly. Out of curiosity, is Ukrainian Sign Language different from
Yes,
English?
there is own grammar and structure.
Oh, okay.
On the first case, we can think that word order is the same in Ukrainian, but there is калькована жестовом
I think it would be effort very well spent on collecting a large body of texts in sign language and then using deep learning methods to machine translation. Thank you.
Thank you very much.
So, any more questions? Well, if there is no more questions, I propose to make a coffee break till 12:30, and I'd like Marianna to host the second part of our workshop.
Well, thank you. I will take over. Yes, I will take over chairing the session. So
Thank
see
you
you
very
after
much.
the break. See you after the break. Yes.
On these links.
Yes, using the same link. Yeah.
Thank you.
Okay. Thank you.